Okay, so question number one. Question number one is one of those V equals D over T questions that has two sections to the trip. So it's kind of like the elevator question from yesterday, except that the marathon racer doesn't change direction, which actually makes it a little bit easier because it's always forwards. Okay, all that's happening is he gets tired and slows down, right? We're just trying to calculate his average velocity over the whole trip. Okay, so the first thing that they should get a mark for is if they got some givens written down, or maybe they drew a picture, okay, with the arrows like I drew with the elevator yesterday, okay, that would be fine. Okay, so give them a mark for givens. If I want to find the average speed of the runner, I need total distance and I need total time. In part one, I was told he can run at 7 meters per second, and he does that for 1.2 hours. Well, what's the problem with hours and seconds? Okay, I don't have distance, but they're also not the same. Okay, I have to convert the hours into seconds. Okay, so I do that by multiplying by 3,600, and I get 4,320 seconds is how long in seconds 1.2 hours is. Okay, so we'll give them a mark if they did a calculation where they converted the hours to seconds. Okay, we'll give them a mark for that. Okay, their next mark is that, like you said, I don't have the distance traveled in part one, but because I have V and T, I can find it. Right, so I'm going to take D equals V times T and get 30,240 meters. Okay, so give them a mark if they had that step there. Okay, now I know how far this person has run because I know how far they ran in the first part and they told me how far they ran in the second part. Okay, so I have the total distance. What I don't have yet is the total time because they didn't tell me how long the second part took. But again, they gave me enough information to find it. So their next mark will be for calculating T in part two. So T equals D over V. Okay, that's 10,600 over 6.1. So if they did that, okay, give them a mark for that method mark there. Okay, and that should have come out to 1,737.705 seconds. Everybody with me so far? Okay, I now have every piece of information about this whole trip. I've got the distance in both parts. I've got the time in both parts. Now all I have to do is get my totals. Okay, so their next mark is for recognizing that average velocity is total distance over total time. I will accept if they went straight to this step, okay, where they added the 30,240 plus 10,600. So if they have either one of those, okay, that'll be their fifth mark. Okay, they'll get another mark for showing the totals. Okay, if they didn't show the totals, it's not that big a deal. Okay, so we got the total distance is 40,840 meters. That's a marathon, 40.84 kilometers. Okay, and that took them 6,057.705 seconds. When I divide those two things, that's total distance over total time, I get that their average speed was 6.74 meters per second. Okay, if they rounded off to 6.7, okay, I'll take those rounding things because I haven't talked about how you properly round, which is what I'm going to talk about right after this so that we do it right from now on. Okay, yeah, so let's say if they've got 6.5, they did a lot of rounding earlier on, okay, but they still did the method right. As long as the method is right, they're okay. Okay, any other questions on that one? All right, does everyone follow what we did there? Okay, kind of, right? Sometimes if I want to get to total distance and total time, I've got to use intermediate information to get all the other pieces. All right. Okay, I don't know if anybody's seen this I don't even know if it's on Netflix. I hope not, because next to Bill and Ted's Bogus Journey, this is like the worst movie ever made. And then Master and Commander would be like right underneath that. Okay, at least in my mind. I don't know if anyone's seen any of those movies. Don't! It's like, it's 2 hours of your life you'll never get back. They're that bad. Okay, anyway, in the Cannonball Run, which is this like poor 80s comedy, okay, it's a race across country, across America to, and they would get, I can't remember what the prize money was, but it was a big amount of money. Okay, anyway, there's a whole bunch of ways to do it. They don't care how you get there. There's really no rules except whoever gets there first wins. Okay, so there's this like Saudi prince who has like a Lamborghini Countach, okay, which is like the original one from the 80s with the gull-wing doors. Okay, that they were driving, and then there was like these like rednecks who had like this big jacked up 4x4 with the big mudding tires and all of that. These are the two people we're comparing. Okay, obviously, if you're driving a Lamborghini Countach, you are not going off-road. Okay, because you'll scrape the bottom off on speed bumps if you're not careful. So they have to stick to the highways, but that they can go 110 meters per second. They also have to travel a lot further because they got to stick to the highways. Okay. Meanwhile, okay, these other guys, they can go anywhere they want. They can take dirt roads, back roads, no roads. Okay. They can travel at 32 meters per second, but the shortest route between 2 points is a lot shorter than having to follow all the roads. Okay, so they're going to only go 295. We're looking for who will win. Well, what determines who's going to win? The time. Okay, because we know their speed and distance is different, but it's who gets there first that matters. All right, so I've got a couple of calculations. First off, give them a mark if they wrote down some givens somewhere. All right, next mark, determining the time it takes the car to complete the race. So that is going to be T equals D over V. Okay. 980,000 meters, we got to convert it to meters, okay, divided by 110 meters per second. Okay, when we do that, we find that the car takes 8,909.1 seconds. Got to do the same thing for the truck. Okay, so we're going to take that distance, 295,000 meters divided by 32 meters per second. Okay, gives us 9,218.25 seconds. So give them a mark for that. Okay, so we're up to 4 marks here. Since this time for the car is smaller than this time for the truck, that means for 1 mark, the car wins. Okay. Incidentally, there is this scene in this Cannonball Run movie where the Lamborghini Countach is skipped across a body of water like a rock. Okay. Yeah, it's actually pretty cool. They're going really, really fast, and there's this like body of water because this bridge is out or something, and they actually the Lamborghini hits it and skips off of it, bounces off like you would skip a rock off the water. Okay, and then recently, MythBusters checked to see if that could actually happen, and they found it could. Yes, you could actually skip a Lamborghini off the water. The reason it has to be something like that is it has to be a mid-engine car. That way the balance point is in the middle. Otherwise, as soon as you leave the ground, the nose goes down because that's where all the weight is. Okay, but in a mid-engine car, it actually stays a little flatter and bounces right off the water. Okay? Now, they did crash the cars that they tested because it was very hard to control the car after it skipped off of the water, okay? Because you've essentially jumped, and that tends to break things in the car. Okay. All right, so the whole quiz is out of 12. So give them a mark out of 12. Okay. And then put it at the top, let them see it, and you can pass them to me up here. All right, so we've got our bus here that's traveling 2 sections to this trip, so it's very much like the marathon runner. Okay, it's traveling with an average velocity of 21 meters per second for 11 kilometers. Okay, and then it travels 1 kilometer at a smaller velocity of 4.2 meters per second. So if I'm drawing the first part of this trip, okay, I would have 11,000 meters. I'm just going to do that conversion right away. Okay, 11,000 meters. Oh, and this is the one where I said take the velocities out. Remember I said it was a typo? Okay, and I was looking for speed. So we were to take those parts out. So it goes 11,000 meters, and it does that at a speed of 21 meters per second. Then it travels 1 kilometer. So 1,000 meters, and it does that at a smaller velocity, or speed, sorry, of 4.2 meters per second. Okay, we want to find the average speed of the bus over the entire trip. Okay, what 2 things do I need for average speed? Total distance and total time. I got the total distance. It told me how far each section is, so that part's done. What I don't have is the time for either section. But just like the marathoner question we just did, okay, I have D and V for both parts, so I can calculate it. Okay, so for part 1 here, I'm going to manipulate V equals D over T. Okay, so I got v equals d over t. I'm going to manipulate it for t by moving t over here, dividing both sides by v, okay, and I've got the formula for time. So time on this one is going to be 11,000 divided by 21. Whoops, not 3 ones. Okay, so the first part takes 523.809 seconds. Now, in terms of rounding, because we were also going to talk about that at the same time, whenever you're doing physics calculations, chemistry calculations, even biology calculations, when you get to that, you should always keep all of your decimals until the very end. Okay? You only ever round when you're rounding for your final answer. Otherwise, you should always keep all of the decimals. Okay? Because that makes your answer more accurate. If I start rounding off early, I'm going to use rounded off numbers in my next calculation, which is going to make my next calculation less valid. Okay? Everybody follow me there? Right? Luckily for us, most calculators will either keep those numbers where you can see them, or you can put them in memory or whatever, okay, and have them there. Right? So we do want to keep them as much as we can. So 523.8095. Okay, and there's some other numbers. I'm not going to write them all down, but okay, we've obviously got more numbers than that. Seconds. Okay, and then I've got to do the same thing here. I've got to find the time for the 1 kilometer section. So that's going to be 1,000 meters divided by 4.2 meters per second. And that's going to be like 200 and something, I think. So 1,000 divided by 4.2. Okay, so that gives us 238.095. Okay, again, I'm not rounding off. I'm not writing them all down just to save time. Okay, so they're all there. Now I've got total distance and total time. Everybody follow there. Okay, so now if I want to find the average speed, okay, so average, I'm going to have d total, which is 12,000 meters, divided by the 523 plus 238. Again, I'm going to put all the decimals in when I actually calculate it. Okay, so 12,000 divided by, in brackets, 523.8095238 plus 238.0952381. All right, so that tells me that it's 15.75 meters per second. Everybody follow what I did there? Okay. Now my answer says 15.8. I rounded to 1 decimal place, but in actual fact, my answer should only have 2 digits. Okay, anybody know why? How many digits do all of my numbers in that question have? 2. Okay, there's something we call significant figures or significant digits. Okay, and basically what it means is we can't have an answer that's more accurate than the numbers we use to arrive at it. Okay, we can't suddenly go from having something that was measured to the nearest kilometer, give me an answer measured to the nearest centimeter. Okay, because then suddenly my answer, because of my math, got more accurate, even though I never measured it that accurately. So in the end, my answer here should really only have 2 significant figures, because this has 2, that has 2. Okay, we always go with the least accurate number. Okay, so my answer should actually be 16 meters per second. Okay, I'm not too worried about significant digits in Science 10. I'm just kind of introducing it to you. But the one thing I do want you to make sure you do is keep all your decimals when you're doing your calculations until the very end. Okay, and then you can round off then. Right? Any other ones from the front page that we should go over? Or are there any questions on what I did with that one? Okay, then what I want you to do is start on the back. Whether you're done the front or not, I want you to start on the back. The back has more vector stuff on it. Okay, so on the back, there's going to be more questions where direction matters. And you're going to have to go, okay, well, that's right and that's left. So one's positive and one's negative, and take that into account more so than what was on the front of the page. Okay, so I'll have you start on that, and then we can go through a few if they give you trouble, okay, as you go along. Okay, on question number 2, we've got, we travel 45 kilometers north to go to Peters. Yeah, Peters rocks. Everyone's eating at Peters, right? Okay, if you haven't eaten at Peters, you have to eat at Peters sometime. Peters is awesome. Okay, yeah, and don't order a large fries. Okay, a small fries is like a child's shoebox full of fries. A large fries is like Shaquille O'Neal's box of shoes full of fries. Okay, yeah, you've got to share that with somebody or you'll get sick. Okay, all right. After your meal, you drive 15 kilometers to Chinook, and the trip took you 1 hour. Okay, so you have to drive south, obviously, to get to Chinook from Peters because it's north of it. Okay, so what we're looking at here is that we went 45 kilometers north, and then we went 15 kilometers south. All right, what was my total displacement? 30, right, because I went 45 up and 15 down. Okay, so my total displacement there is 30 kilometers. And my total time is 1 hour. All right, so average velocity then is total displacement over total time. 30 over 1 is 30 kilometers per hour. People do have a tendency to, on this one, to change units around. Okay, because a bunch of the ones I've done, I've changed things to seconds and got meters per second. Did it ask, if a question doesn't ask for meters per second and the units are matching, don't bother changing. Okay, because you're just doing extra work for no reason. Okay, we can leave this one in kilometers per hour simply because we're given kilometers and hours. Everything's in kilometers. All the times are in hours. There's no need to change. Everybody follow? Okay, that was all I kind of wanted to say about that one. It wasn't very hard mathematically. Okay, it was just make sure you're not changing units if you don't need to. Okay, it's just extra work. Anyone's giving us trouble on that we need to go through? Cody? 3? Okay, so we got a jet that goes 30 kilometers per hour east for 45 minutes, then hits a storm and is forced to turn around, so it travels west at 375 kilometers per hour for 30 minutes. How far did the plane travel? What was its final displacement, average speed, okay, over the entire trip? All right. Can't really draw a line for this one because I don't have the distances yet. Okay, I don't know how far it traveled in each part. Can I calculate how far it traveled in each part? Yeah, because I've got the speeds, or sorry, the velocities and the times, but the time is in minutes. So what do I need to do with that? Change it to hours so it matches the kilometers per hour. 45 minutes is 3/4 of an hour and 30 minutes is half an hour. Okay, so for part 1, I'm going to have a velocity of 350 kilometers per hour east and a time of 0.75 hours. Okay. In part 2, I have a velocity of 375 kilometers per hour west, okay, and a time of 0.5 hours. All right, now I can calculate D for both parts. D equals T times V. Okay, that's the manipulation of V equals D over T there. So 350 times 0.75. So 350 times 0.75, and it gives me 262.5 kilometers east. All right, going to do the same thing over here. D equals T times V. That's going to be 375 kilometers per hour times 0.5 hours. Okay, so it's 187.5 kilometers west. Okay, now that I've got the two distances, I can draw that diagram. Right, so I'm going to have my west line here that's going to have a displacement of 262.5 kilometers. Okay, and then I'm going to have the other one that goes back 187.5 kilometers. Everybody with me so far? Okay, so it asked me to calculate the total distance traveled. What do I do with those two numbers to get total distance? Just add them, because distance is scalar. It doesn't care whether it went backwards or forwards. Okay, so the total distance traveled is 262.5 plus 187.5, okay, which gives us 450 kilometers. Everybody okay with that part? All right, to get the total displacement, okay, I went 262.5 this way, and then I went back 187.5. So what do I have to do with those two numbers? Now I have to subtract them or add them, making the 187.5 negative, whichever way makes sense. Okay, so when I subtract those two, I'm going to get 75 kilometers east of where I started, because here's where I started, okay, and I did end up 75 kilometers east of that. Now, average speed. Which do I use? The 75 or the 450? The 450. Okay, I got to use total distance divided by total time. Okay, I haven't calculated total time yet, but it's not hard. It's 1 1/4 hours. Okay, 3/4 plus a half is 1 1/4. Okay, I can do my total distance over total time. Okay, so 450 divided by 1.25, and that should give me my 360 kilometers per hour. Okay, no direction on that because it's speed. Any other ones giving us trouble? Okay, so guys, expect that if I ever ask you to do problem solving with v equals d over t, it's probably going to be a two-part question. Okay, just asking you to do a v equals d over t calculation with one simple calculation is not really worth 4 marks. Okay, I mean, you guys can do that, you know, with your eyes closed probably. So you're probably going to get something a little more involved like this. All right, keep working. We'll see if any more come up. Okay, so on number 5, we got the kid on the scavenger hunt. They run at a velocity of 6 meters per second for 30 seconds due east. All right, I can't draw a picture because I don't know how long to draw my arrow right now. I'm not given the distance for the first part of his trip, but what I am given is his velocity, 6 meters per second east, and his time, 30 seconds. All right, the child then gets a hint and turns to run due west at a velocity of 5 meters per second for 55 seconds. So his velocity is now 5 meters per second, but now it's west. And the time is 55 seconds. Okay, can I find out how far, well, actually, what his displacement is in each of those parts? If I know v and t, can I find d for each part? Yeah. So v equals d over t. So to find d, I'm going to multiply both sides by t, and there we have it. So that'll be, for this one, 30 times 6 equals d, which is 180 meters east. Everyone follow me on that one? Yeah. Okay, and then for the second one, same formula, d equals v times t. So 5 times 55. Which is 275 meters west. All right, now I can draw that diagram of the kid's trip. So we're going to have 180 meters. Okay, displacement of 180 meters that way, and then he's going to come back 275 meters. All right, so if the kid started right here, his displacement is from here to there. Everybody all right with that? All right, so I'm going to say then that I'm going to go 180 plus negative 275, or you can go 275 minus 180. Doesn't really matter. You're going to get the difference here, okay, on that one. So 180, okay, plus negative 275 tells me he ends up 95 meters west of where he started because I assigned west as negative. All right, so his total displacement, okay, is 95 meters west. Okay, what's the speed of the child over the entire trip? Do I have the information to get that right now? What two pieces of information do I need? Mason? Total distance and total time. Does the east and west matter anymore? No, it doesn't. Okay, speed is scalar, distance is scalar. So what do I have to do with the 180 and the 275? Will, what do I do with them? To get total, right, to get total distance, I add them together. Okay, and then the total time will be 85 seconds because 30 plus 55. So we'll have our 275 plus 180. Okay, and then we'll divide that by 85 seconds because that was the total time. Average speed 5.4.
Good morning, everyone.
Meters per second.
I would ask